What's up, guys? Actually, I wanted to start this video by in-depth comparison of different supercomputers and their potential use cases, but for some reason I cannot get the Golem app to run on my computer at all. So basically we have to skip this step. No creepy ass in 3D rendered today. Anyway, before we start, we have to make sure that Elastic is actually running locally, because the entire software package that I've written is using a local instance of Elastic. Of course, you can use some public API and skip the requirement to install everything on your computer, but it's easier for now. So make sure it's running, you're connected to some nodes, at least one super node, and from that point you can start. So what we're gonna do today is show a real use case. Well, people have been writing little Elastic PL snippets and adding numbers, finding prime numbers and stuff like that. But every now and then someone popped up in the forum and asked, what the fuck is possible with Elastic PL? I mean, can we do something really useful? So yes, I think we can do pretty much something useful, and one example that I thought of is actually mining a real Bitcoin block, because this is a very real use case that probably many people would be interested in. So, first of all, we have to code the mining algorithms actually in Elastic PL. And if you take a look at one possible Elastic PL program, you will notice that it's really low level. So nobody with a serious whatever would be actually writing a program in Elastic PL himself. So what we need is a meta level, basically, so that we code our programs in Elastic PL through other programs that we code. Sounds strange, but this is actually what I did to create the Bitcoin mining logic in Elastic PL. So this is basically a Python program which actually implements the whole SHA-256 double algorithm in code. So let me go through this quickly. We have the block header actually. To keep it simple, right, I mean, there's only one miner active at the moment. It's my own one. So let's keep it simple and let's mine a very simple block. So I took the Genesis block, and this is actually the 80-byte block header, right? I have taken out the nonce because this is actually what's mining about, finding a nonce that causes the SH whatever hash to start with several leading zeros, right? So nonce is 0, and this is actually what we aim to find through this supercomputer. So and what we basically do is actually create a Python program that will use our block header and the SHA logic to produce a valid Elastic PL program. So when you scroll through this, you can actually find it on GitHub. You will see that this is actually correct. So we initialize the initial state, the K array. Since SHA works in 64-byte blocks, we have to hash the 80-byte block header in 2 chunks. So we basically initialize the first chunk. You see it here. We take 16 integers from the Genesis header and assign it basically. It's too complicated to go through every single step. But actually we take the header, we process the first chunk, we take the second 4 integers of the header, process the second chunk, then we reinitialize the whole SHA algorithm because we need to hash the hash. So basically it's a complete new hash operation. And then we process the chunk. And the trick is the verify line. So every elastic PL has a verify line, and if the verify line evaluates to true, the miner has found a bounty and gets paid for it. So we check, the hash will end up basically, the state array is 1000 to 1007. So this is actually the place where the hash will end up. So if the hash, actually it's little endian, so the last entry is the first part of the hash. And if this is 0, so we have actually 8 leading zeros, so then we found the block, basically, because it starts with enough leading zeros. Okay, I've been talking too much about this Python snippet, but actually this will generate the elastic PL code for the miner. Let's do it. Prepare EPL to test, and this is actually the program that we will upload to the network soon. Take a look at this. You see it's a pain in the ass. You don't want to code that by hand, but you know, if you use a meta language like Python to create your elastic PL programs, everything is just fine. Great, so this is actually our miner, and we are looking for a nonce that makes this block header hashed twice have enough leading zeros. Great, so let me first start the miner. No, I will start it in a minute. So now that we have this elastic PL program, we need a second part that will actually manage uploading the work, collecting results, and then building actually something from these results, because the result that we get is just a number. It's the nonce, basically, right? But for a complete miner to work, we actually need to take the nonce and then generate a block, basically, right? I mean, we cannot submit the nonce alone to the Bitcoin network. So basically, this is what my job.py does. So this is basically some configuration parameters. It has functions to push work to the blockchain. It's actually the source file, which we call test. This is this one, our mining algorithm in elastic PL. And then we have some some watchdog. It actually tells you if the work has started already, how many bounties you have collected, and then when the bounty is actually found in a network, we are pretty much done, because we only need one nonce. No, this is not an algorithm that needs several results. We only need one. And then from the combined storage that gets returned by the blockchain, we take the second entry, and then we take the block. I actually took the hex representation from blockchain.info. And then we put the nonce in it, and there we go. Okay, too much talking. Let's take a look at how this thing works. So we start our miner, my job. Work has been submitted to the blockchain. You see it here, unconfirmed transaction. So we have to wait a minute basically until it confirms. So you will see it here, unconfirmed work. Yeah, we have to wait. I know. Takes about a minute. I've been thinking about making the block time a bit shorter, so results get quicker. But this is something we can actually discuss in the forum. So let's wait. Damn, I wish I could render that walking butthead, but didn't work. There you go. So, fuck, I clicked. Python generated work is online, waiting for results. There you go. I didn't start the miner yet, so it didn't mine right away. So let's start mining. And let's wait. Okay, let's see. We will wait until the bounty comes in, so we know everything worked. Okay. Miner is working with, it's not that fast because Honestly, my algorithm is not the fastest. There's a lot of optimization potential. There you go, bounty found. So it must be somewhere here. Bounty has been found. Now I have to wait for a block that my watchdog collects the bounty and generates my Bitcoin block. Let's wait a second. There you go. Yeah, that's slow. That's slow. Oh, there you go. Bounty has been not claimed. Okay, so while the result is already there, I could have actually pulled it from the unconfirmed transaction, so I would be done already, but I didn't put that much effort in it, so actually the watchdog waits until the bounty gets confirmed. So there you go, block found, bounty confirmed, and this is the finished Bitcoin block, ready to be pushed to the block Bitcoin network. Submit block. There you go. And you see duplicate inconclusive. That means, yeah, the Genesis block has been mined already, so it's a duplicate entry. But there you go. If this would be a new Bitcoin block, you could have just submitted it right to the blockchain, and there you go. Right, that's about it. It's a semi-automatic thing right now, but it's just a proof of concept, so I think that people who are more fancy than I am could come up with something completely automatic, and yeah, there you go. So I will check in everything on GitHub in a few minutes, and make sure you update Elastic Miner, and make sure you update your Elastic Core, and if you like, you can just play around with it, submit your own Bitcoin mining task and see how it gets mined. Very cool thing, and this is actually a real use case that you can do something with, right? And if you can do something that complex like mining Bitcoin blocks, you can do pretty much anything, right? Like the golden people told us, sky's the limit, so it's up to your imagination what you do with it. So have fun with it. Maybe someone of you has a nice idea how we can introduce a meta language actually that will create Elastic PL programs from maybe Python or C programs, maybe something better than actually this, but it works fine. The thing is, in Elastic PL we do not have any variable names, so programs become very messy. But if you have something that gives a meaning to all these numbers and everything, I mean, here you can actually see, okay, 3014, that's actually the second header chunk initialization. So right, anyway, you see it worked. Miner is not yet that stable, so today I will spend the rest of my Sunday making everything stable and nice, and making the super nodes more reliable, but you can start testing right away. So have fun, guys. Thanks for watching, and I hope you enjoyed.